Hello and welcome to the 2020 series Ears to the Ground, organized by the Corn and Soil Health Project at the University of Illinois. Today we are going to talk about corn produced for organic poultry with Walter Goldstein from the Mandamin Institute. Welcome, Walter.
I'd like to talk today about the work that we're doing on the CASH trial with some of our hybrids, which we bred for high methionine and also for high keratin content. We're concerned about addressing the needs of organic poultry producers who need to have a higher quality grain protein in order to meet the needs of their birds. Hard to do it with just using synthetic methionine. They're allowed to do that at this time, but that input will be gradually phased out, so we need to find a replacement. We've prioritized in our breeding program breeding for high quality and trying to combine that with high yields, or at least with competitive yields. Over the 2-year period that we've looked at, we've had about a 9% reduction in yield relative to comparable hybrids for our best yielding hybrid. The second hybrid that we've had in all the trials, it's been over the 2 years of 15% reduction in yield. We have 1 year of data for the quality, which reflects what we've learned before in the past. Protein and its composition in terms of amino acids is important for the quality and the value of the protein for either producing eggs or producing meat in terms of broilers. What we've found is that we have, through selection, increased the methionine and the lysine and the cysteine content of our grain considerably relative to normal corn. In fact, over all the different sites, we had about 50%, 43 to 57% more methionine in the grain than did the conventional hybrids. That's really a lot. In terms of the lysine, it was 9 to 14% more, and the cysteine was 12 to 21% more. So actually, the protein is worth a lot more in terms of its effect on animals. The methionine in the protein was 32 to 36% more methionine in the protein. That means that we've shifted the protein away from proteins that don't really help an animal to grow to proteins that really do foster growth and egg production and the things that a farmer needs. Now, those are often met by feeding soybean meal. Or synthetic methionine. Consumers are not particularly excited with organic farmers feeding synthetic methionine to their chickens. That doesn't seem to really jive with the organic idea. So this and also feeding lots of organic soybean meal results in ammonia emissions because we're feeding a lot of protein to get that methionine to the birds. So having a concentrated quality protein is going to make a difference in terms of feed composition, and that's going to reflect itself in a lower feed cost. So there's actually a value of this higher quality protein in terms of the feed. Right now, we're estimating that may be 20% more value simply in terms of replacing organic soybean meal to feed our corn relative to relative corn in poultry rations. We've also thought and worked hard to try to increase the keratin content in the grain. This is important because the carotenoids are important for human health as well as for bird health. Birds prefer orange-colored grain. They seek it out, and there's even studies that show that young chickens that are hatched out of eggs with very orange yolks survive better. The carotenoids are important for eye health, and in particular lutein and zeaxanthin, which are found in the grain, are actually the same substances found in our retina. Also, the vitamin A producing ability of the grain is shaped by the contents of beta-cryptoxanthin and beta-carotene in the grain. And what we found in our studies is that we're way ahead. We have 11 to 20% more lutein, 32 to 49% more zeaxanthin, and also for the vitamin A containing carotenoids, we have 44 to 164% more beta-cryptoxanthin, and we have 29 to 50% more beta carotene in the grain. So essentially, that enhances the value of eggs. When we have a higher carotenoid content in the grain, it transfers into a brighter orange or brighter yellow color in the egg yolk, and that's been found to be one of the best ways to get carotenoids into the human diet. So what we have here is a way of actually strongly influencing the human nutrition. And we can do that simply through breeding, and we have done that and are demonstrating that now through the CASH project. Here we can see a picture of some eggs that we fed with our high carotenoid corn versus corn fed with a more normal diet, and even did receive some additives to make the eggs even oranger at the bottom. So we have seen when we've looked at different markets in the big cities that people will pay more for orange eggs. And we've consulted with a company in California that's selling very bright orange eggs, as well as normal eggs. They're selling organic and conventional eggs, conventionally produced eggs. And the orange eggs bring more money. We've seen that in the big cities in the Midwest and also on the West Coast, up to $7 or $8 a dozen, whereas normal, say, organic eggs often are bringing something like $3.50 a dozen. So there's a real value associated with quality corn in terms of what it can do for not only influencing the health of the consumer, but also influencing the price that farmers can get. So these results in general are showing that what we've done is we've increased the quality of the corn. Beyond, there is a yield reduction that we've seen 9% over the 2 years or 15% for the somewhat earlier maturing corn variety, second variety. However, the quality puts it in a different category in terms of its value. And I think that's kind of the end of the story. But there is one other important issue, and that is the mineral content. I don't know if many of you have heard arguments that we've been breeding for yield, and somehow we've reduced the nutritional value and the mineral content of our crops. This is something that's actually known and debated in academic circles. What we're finding, we have found before these studies, was that the breeding of our corn has been associated with a greater mineral content, in particular boron. We have over all the different sites, we have 9 to 15% more boron, 23% to 32% more iron, 21 to 43% more manganese, 13 to 57% more copper, and 9 to 14% more zinc. So essentially, we've been breeding for mineral density or nutrient density in our corn, and we've achieved it. This is a different way of looking at corn, which is generally viewed as number 2 commodity. And what we're finding here is that we're producing something that's quite nutrient dense and has potential for shifting the way that we view corn and the kind of corn that we grow.